Definition of polynomial expression. Definition. A polynomial expression p of x can be written in the form like this, where n is a non-negative integer. And here we also have to remember that all the a's in this polynomial expression right here are real numbers, such as the a sub n should not be equal to 0. And here is the a sub n. So this polynomial expression is said to have a degree of n. And now let us proceed with some terms related to polynomial expressions like this. And here we have an example of a polynomial. And now the term containing the highest power of the variable x is called the leading term. So here in our general expression, we have the leading term to be a sub n x raised to n, while here in this example, you only need to consider the highest exponent, and the term containing such highest exponent would be the leading term. And in this case, we have a negative 6x raised to 4. So next, let us have the coefficient contained in the leading term is called the leading coefficient. So since this is our leading term, the coefficient, which is the a having a subscript of n, would be the leading coefficient. And here in our example, since this is the leading term, the numerical coefficient of negative 6 will be called the leading coefficient. And for the next term, we have the power of the variable x contained in the leading term is called the degree of the polynomial n. So again, we are talking about the leading term here, and this is our leading term. So this implies that the n would be the highest exponent here, such as in our example, this is our leading term, the highest exponent would now be the positive 4. And this is the degree of such polynomial expression. And for our next term, we have the real numbers, a sub 0, a sub 1, a sub 2, or simply all the a's are the coefficients or constants. Here we have our constants to be the negative 6, positive 8, negative 1, and followed by a positive 10 and a negative 7. And the next would be the term containing the real number a sub 0 is called the constant term. So looking at our general expression, we have our a sub 0 here. And you will notice that there's no variable. So we have our constant term to be such term without the variable x, which happens to be the negative 7. And now let us proceed with identifying polynomial expressions. So here, we would like to identify which of the following are polynomial expressions. For number 1, it is a polynomial expression. So let me just have this be marked with a check. Okay, so I will be marking all the polynomial expressions with a check. And looking at the other one, you will notice that one of the conditions for having a polynomial expression in the definition is to have our n be not equal to 0, as well as it should not be a negative number. Okay, so let us mark this. So this is the reason why is it that this expression is not a polynomial expression. So let us simply mark this with an X. And for the third one, so this is a polynomial expression. In grade 9, you have already encountered the exponential expression. And having a negative exponent like this results into something like this. So that means this expression here is basically the same with this one. So this implies that there should not be an exponent in the denominator. But in this case, you will notice that our denominator only contains a constant. So for as long as the denominator doesn't contain any variable, then this will be a polynomial expression. And now for number 4. So notice that it is basically the same with the third one. And this would be a polynomial expression. Having each of the term to have a denominator of 7, since we do not have a variable in the denominator, this will still be a polynomial expression. And for number 5, here is another counter example. So this is not an example, a polynomial expression, because the exponent should be a non-negative integer. So integer implies that the number is a whole number. And by looking at this, we have an exponent which is a fraction. So this is not a whole number, so this is not a polynomial expression. And for number 6, notice that there is a variable in the denominator, so this is not a polynomial expression. For number 7, here you will notice that the exponents are non-negative integers. The coefficients are real numbers, so this will still be an example of a polynomial expression. But for number 8, this is not a polynomial expression because you will notice that this is not an integer. While for number 9, this as well is not a polynomial expression. So remember that if you have, let's say, an expression like this can be translated as x raised to 1/2. And this is actually a lesson in the grade 9. And for number 10, here you will notice that yes, we have a radical expression, but notice that the only expression inside this radical is the 3. So having our coefficient be the square root of 3, not the x. So this will still be a polynomial expression for that reason.